Since I have other detailed lectures, podcasts on El Nino, I'm going to jump straight to the current status. We will steal material from NOAA. We are attributing the source, so it's okay. This is from the Climate Prediction Center of NCEP, National Centers for Environmental Prediction, National Oceanic and Atmospheric Administration of the US. And so recent evolution, current status, and predictions just came out on 15th June, I think. They put it out about every month, but during an El Nino, they do it more often. Uh, I say here every ENSO is different. ENSO is El Nino Southern Oscillation. We'll come back to this terminology a little bit later. I will keep going back to basics, but keep coming back to 2026 with some level of technical details that hopefully you are aware of. So even though every El Nino looks different, they all have a life cycle. They have a precondition stage we will look at, which has already happened. They have an onset stage, which has already happened. It's already in the growth stage, but main growth will happen later in the summer, July, August, September into December. And they have a mature phase, which is typically December, January, February. So it'll be December of 2026, January, February of 2027. And then it decays. Sometimes it decays very rapidly. Sometimes it lingers on, and sometimes it decays slowly, and so on and so forth. And this is a nice way to look at it. This is looking at sea surface temperature anomalies averaged over 5 south, 5 north of the tropical Pacific, going from 120 east longitude, which is near New Guinea, towards 80 west, which is near the South American coast in the eastern tropical Pacific. We are going here from July 2025 to June 2026, the latest data that NOAA shows. You can see the east-west contrast in July 2025 last summer. There is a slight warming here, but basically it's a cold state, so you can think of it as anomalously cold. So it's a La Nina state, a weak La Nina state. The colder state got stronger and spread more to the east and went on into the spring of 2026. So March 2026 is still cold, but you can see in the far east of the tropical Pacific, right here along the coast of the South American and North American coast, there are warm sea surface temperatures, and the warm SST anomalies from the west began to spread eastward, and they have now occupied pretty much all of the tropical Pacific up to about the dateline and beyond to the west. And you can see whenever there is cold SST anomaly here, we have stronger trade winds pushing the warm pool more to the west. As we said, warm pool tends to be warmer, so you can see that there is a slight warming here, order half a degree or so. But now we are getting into 0.75 to 1.5 degrees centigrade across here. This is where the ocean also begins to feed back. And you have cold SSTs here and high pressure here, low pressure here. You have anomalous winds going from high pressure to low pressure, which will only reinforce the upwelling because more water is being pushed to the west away from the equator, and more cold water can come up. Whereas when you produce warm waters here, then the pressure drops. Warmer sea surface temperatures produce lower pressure, so you weaken the sea surface temperature gradient, cold to warm. Now it's almost flat, and the sea level pressure here may even go up because it's colder. So anomalously low pressure, anomalously high pressure. So you have completely reduced the east-west pressure gradient, which means you're also going to weaken the wind. So if the trade winds have weakened to produce these warmer SST anomalies in the east, they will get further weaker because now Upwelling is weaker, temperatures are weaker, sea surface temperature gradient is weaker, and sea level pressure gradient is weaker. This is a positive feedback, which also involves the thermocline below, as we will see later, called the Bjerknes feedback. Jakob Bjerknes proposed it in 1969. So you can see so far from 17 May 2026 to 13th June 2026, there are warm sea surface temperatures with a pattern that looks like this. Colder sea surface temperatures on this side, which is very typical. This tends to have this kind of a horseshoe shape, which has to do with the waves in the ocean, because waves also occur in the ocean, not just currents. Just like the atmosphere, you have winds, but you have also waves, right? So waves can move much faster than the winds or the currents. Ocean currents move very slowly, order centimeter per second, whereas in the atmosphere they can move at tens of meters per second speed. So ocean moves like molasses, but waves can move at meters per second also in the ocean, and we'll see what impacts they can have. Every El Nino looks different because you can look at the evolution further of the temperatures over the last couple of months. This is also from NOAA. You can see how seasonal cycle during March, April, May brings the regular warm sea surface temperatures here, but they are also anomalously warm, as you can see here. So this is the anomaly for the same period, and you can see the SST sea surface temperature anomalies here are warmer than normal. Indian Ocean is doing something, Atlantic Ocean is doing something. All these things matter in the end as to how the monsoon responds, how the hurricanes respond here, how the typhoons respond here, what the cyclones do in the Indian Ocean. Of course, we have a pre-monsoon cyclone season and a post-monsoon cyclone season, and so on. You can also see briefly the subsurface response. We are looking again from west to east, but now below the surface. So you can see warm sea surface temperatures near the surface, but of course you have warm temperature anomalies below the surface. They start from the east and move towards, so they start in the west and move towards the east. Okay, we'll define later what these things mean, but this warm water is sitting there and it's moving from the west to east over many months, and it gets pulled up here along with the upwelling. Remember, upwelling doesn't disappear, so instead of cold waters coming up, now you can bring anomalously warm waters which make the surface warm, and then you have this positive feedback between the winds, the upwelling, sea surface temperatures, thermocline, and of course back to surface pressure gradients and winds. Okay, I will leave it here and see how bad the sound is, because there is some horrendous banging going on here in my apartment. Okay.